Alright, so part 2 of scalars and vectors. So this one is still part of the same homework assignment, alright, and the form that you have to fill out is related to this video as well. Just add some extra notes onto what you took from the last one. Alright, but let's get into adding scalars and vectors. Since they work differently, adding is going to work a little differently too. So if you remember from the last video, scalars are pretty simple. It's just a number and a unit. The adding is really simple too. All you have to do is add values together. Now, one thing I want you to note that might end up causing mistakes in the future is note that right here I have the same units. They must be the same for you to do this, okay? And if I were grading this, I would have lost points because I didn't add units to my answer, okay? So make sure the units are the same. That's the big thing to remember there. You can't add 5 meters and 5 centimeters. That's not 10 centimeters, okay? You'd have to convert one to the other unit. We'll get into that eventually too. But vectors, because there's direction, you kind of have to deal with these a little different. So there's a technique or a rule for how to add vectors. You have to have them set up head to tail. So that means the head of one vector is lined up with the tail of the other. Okay, so let's say this is 4 meters east, and this is 3 meters north. Alright? So what we have is these two vectors added together become this resultant line. Alright? And the resultant line is actually, you'd find the magnitude or the length of the resultant line plus its direction, and that would be the addition. Okay, so it's this line right here that is actually your added vectors, right? To figure out the direction, you always go from the open tail. You can kind of think of that as like the beginning. Then I just spelled that wrong. Begin. There should be another couple of ions in there. To the open head. Okay, so what direction would this be if this was our two vectors being added together? Hopefully you are saying north, east. Okay, another thing I want you to keep in mind is this isn't the only way you could take these two vectors and add them together. Okay, so let's say we start with our (4 meters east). Okay, which end of the arrow would I have to draw the 3 meter north vector below this so that I have it set up head to tail? Hopefully you are saying the tail end or the left side, because if you look, if I put it right here, oh hey, that's still head to tail. Alright, so there's a head and there's a tail being touched together. And then if I draw my resultant again from the open tail to the open head, oh, it's in the same direction, and it would be the same length as the other one. Alright, so those two lines would be the same. So as long as you set it up head to tail, your resultant line will always be the same. Doesn't matter which one you draw first. Okay, unless the story implies that you have to draw one first. But just make sure that you're always setting up head to tail. If you start putting things together head to head or tail to tail, then you're going to start getting resultants that are wrong, and you're going to have no clue how to draw the direction on the resultant either, because you won't have an open tail and an open head. Okay? As far as figuring out the magnitude for adding vectors, you're going to get familiar with something called the Pythagorean theorem. If you've already had geometry, you should have learned this. If you're in geometry right now, you might be learning it at this moment, or you'll be learning it soon. Okay? So let's talk about here's our 4 meters east. Here is our 3 meters north. Okay? And our resultant. The Pythagorean theorem only works for right triangles. Okay? Sorry about that. So you have to have a 90-degree triangle. So this is for right triangles only. Alright, and then if you think about it, what's happening is you have your right triangle always has 3 sides. Alright. There's 2 legs and a hypotenuse. Okay, the hypotenuse is always the long one that's across from the right angle. Alright, and then the hypotenuse is always also referred to as C. The 2 legs, I could say this is A and this is B, or I could flip it. It doesn't matter. Okay? So in order to figure this out, in the length, the magnitude of each of the sides are not the numbers squared, but just the plain numbers. Okay? So we want to find, if we want to find the hypotenuse, the length of the hypotenuse to find our resultant, we want to know what C is, not C squared. Okay, so let's make that look like a good question mark. So C is our question. Okay? So what we need to do is we're going to take this equation, we're going to take our A value, 3, and we're going to square that. We're going to add our B value, 4, and we're going to square that. So you get 9 plus 16 equals, and that's going to be equal to C squared. Right, so 9 plus 16 is 25. Is that our final answer? Hopefully you are saying no, because we want to get C by itself, which means we need to take the square root of that number. Alright, so C is equal to the square root of 25, which hopefully you know your perfect squares pretty well, which means C equals 5 meters. And what do we need to remember? Hopefully you are saying direction. North, east. Okay, I apologize for that kind of being all over the place. But if you have not worked with Pythagorean theorem before, I highly suggest coming into some office hours or asking a lot of questions if you have the opportunity to in class. Right? But especially if in class, with 32 kids, I don't get a chance to answer everything for you, I highly suggest office hours, because you'll be using this a lot. Okay? So, I want you guys to try. So, pause the video, try each of these, and when you start the video up again, I will be going through each one. Okay? So, this one, easy. Alright? There's scalar. So all you have to do is add the numbers. 25 meters. Yay! Hopefully it was just as easy for you. Alright? So draw a vector that shows one hand length to the east. Alright? So, hand length, say it's that, and east is to the right. Big thing for knowing whether or not you did this right is if you pointed to the right. Okay? And then last thing is draw and find the addition of a vector 3 meters west and 4 meters south. I highly, highly, highly suggest any of these problems drawing it out. Okay? It'll help you with the directions. So we have 4 meters south. Alright. And then, let's see, I'm going to draw 2 things on there, and hopefully you'll know which one's correct. Alright, so we could add the 3 meters west down here, or we could add it up here. So, is the top one or the bottom one correct? Hopefully you are saying it is the top one, because that's the one that gives you the whole head to tail thing. So that's the right setup. So I'm going to erase this bottom one. Alright. And then we need our dotted resultant line. Now, should the tail go by the green or the red arrow? I'm hoping you are saying the red arrow because it goes from the tail to the head. Okay. Right, and then we know this is 3 meters. This is 4 meters. And then this is question. We don't know that one. So hopefully you're remembering your Pythagoreans. Now we just did one just like this. But just to review it, if we say this is A, this is B, this is C, we're going to have 3 squared plus 4 squared equals C squared, which is 9, plus 16, which equals C squared, which is 25, equals C squared. And what's the last thing we need to do? Hopefully you are saying take the square root. C equals 5. And then there's a couple of things I need to add before I have my correct and full points. So, need our unit and our direction, southwest. So there's your final answer. Alright, that's the end of the video. Make sure you complete the online assignment. Make sure you have your notes with you in class tomorrow and be ready for your mini quiz. You can always bring questions or post something on YouTube. Okay? See you in class.